Exam based question for CSIR NET, and this is part B question where one option needs to be selected out of 4. Topic is diagonalization of a matrix from linear algebra. Question is which of the following is not diagonalizable over R. So 4 matrices are given to us. Things to remember are, for upper triangular matrices the diagonal entries are the eigenvalues. Means you don't need to find the eigenvalues from characteristics polynomial. Eigenvalues are simply known to us by the diagonal entries, since all the matrices you can observe are upper triangular. So second point is a matrix is always diagonalizable if its eigenvalues are distinct. So if eigenvalues are distinct, for sure matrix is diagonalizable, but if eigenvalues are not distinct, that does not mean matrix cannot be diagonalizable ever. So for this, third criteria is whenever we have repeated eigenvalues, their algebraic multiplicity must be equal to geometric multiplicity, that is AM should be equal to GM. And the last one is the relationship between AN and GM is like 1 less than equal to GM less than equal to AM. That means in this case, if AM is 1, for sure GM has to be 1, and this is the only case where we don't need to check about their equality. They are equal always. So now based on these properties, you can easily see matrix B and matrix D are clearly diagonalizable because their eigenvalues are distinct. Eigenvalues of B and D matrices are distinct, so B and D are diagonalizable over R. See, over R means your eigenvalues are real. Now for matrix A, we can see eigenvalues are 1 and 2. 1 is repeating twice, so algebraic multiplicity for 1 is 2, means it's repeating 2 times. So for eigenvalue 2, AM is 1, and in that case GM is also 1. For eigenvalue 1, AM is 2, we need to find the GM. So to calculate GM, there is a formula. 3 minus 3 is the number of columns of the matrix minus rank of A minus lambda I, where lambda will be the eigenvalue for specific eigenvalue for which you are looking for GM, and A minus 1I will be here. After calculation you can see, and after row reduction the rank we can come to know. Rank of this matrix is 1, so substituting rank here, 3 minus 1 is 2. So in this case also AM is equals to GM. So A is also diagonalizable by property 3, which we have discussed inside. So by this I can clearly say C is the matrix which is not diagonalizable over here, but still for confirmation we are checking. Eigenvalues are 1 and 2. 2 is repeating once, so in that case GM will also be 1. And for 1 eigenvalue AM is 2. For GM, 3 minus rank of A minus 1I, we need to find A minus 1I matrix. So in this case you can see the rank is 2. So 3 minus 2 is 1. So in this case GM is 1. AM is not equals to GM, that is why C is not diagonalizable.